Hello everyone, I'm Snigdha Kakkar and this is my channel AccelerateAICareers. Today we are going to solve LeetCode 135 Candy. The hard level LeetCode problem has been an all-time favorite for Google, Amazon and Meta in their last 1 month of software dev interviews. There are 8 children standing in a line and each child is assigned a rating value given to them and there's an integer array ratings provided to you as shown in the examples here. You are giving candies to these children subjected to the following rule. The first rule is that each child should have at least one candy, that is, bare minimum number of candies you can give to a child is one. And children with a higher rating than one of its neighbors, either next neighbor or right neighbor, then it should get more candies than that particular neighbor. And you have to return the minimum number of candies you would need such that these two rules are met while distributing the candies to the children. So let's look at some examples to understand how the question can be solved. So the first example you have is ratings equal to 102, where your first child is given rating as 1 and its neighbor has rating 0. So it has more rating than its right neighbor. So it should get more candies than this child. Suppose we give bare minimum 1 candy to each child as indicated in the first rule. And then the child has more rating in this than its neighbor, so it should get 2 candies, bare minimum. Now it can get more than 2, but since we have to return minimum number of candies, I'm taking just 1 increment. Now the second child, which has 0 ratings, does not have more rating than any of its neighbors, so it is good with 1 candy. The last child has ratings as 2, which is greater than its neighbor, and thus should get more candies than its neighbor, which should be 1 plus 1, that is 2. So the total number of candies which are required minimum to follow the 2 rules is 2 plus 1 plus 2, that is 5 candies. And that's your output here. Now let's look at the example 2. In example 2, you have been given a ratings array 1, 2, 2. Now the first child has 1 rating which is less than the second child's, hence can go ahead with just 1 candy. The second child has rating 2 which is greater than its left neighbor. Hence it should get 1 candy more than its left neighbor at least. So it should have 2 candies. Now the third child has equal rating as its prior neighbor. So there is no such rule indicating that if you have an equal rating you should get more candies. So hence it can go ahead even with 1 candy because it doesn't have a higher rating. I hope you understand this. Now let's look at another example which I have 2, 3, 4, 5. So in such a scenario, how we should solve this question? So let's take a left pass, start from 0th index of the array and start going to the last index and check for all of the left neighbors. If you have more rating than any of the left neighbors, in such a scenario, you increase the number of candies accordingly starting from 1 candy. But then you would say we are not checking for the right neighbor and we don't know how many candies actually the right neighbor has. So we cannot even increment by 1 or more, right? So I take a right pass, that is start from the last index and go towards the 0th index and then check for every right neighbor and see if I have more rating than the right neighbor. If I have more rating than the right neighbor in such a scenario, I increment by number of candies. So essentially, I have to take 2 passes. I have to start from 0th index, go till the last index and check for all the left neighbors and increment my candies accordingly. And similarly, I have to take a pass from the last index to the 0th index and check for all the right neighbors. In such a scenario, I don't need to include the starting index when taking a left pass because the starting index value does not have a left neighbor. So essentially, it can start with 1 candy. Similarly, when I'm starting backwards and I'm starting from the rightmost index, in such a scenario, I don't need to start the rightmost index because it doesn't have a right neighbor. So I can start with the prior index. I hope you understand that exception. And what would be the time complexity here? The time complexity here would be O of n since you're taking 2 linear passes for the array. So time complexity would be O of n. You are using another array to store the number of candies. So space complexity would also be O of n. So let's start coding this question. So I'll initialize my candy array by ones, that is the minimum number of candies given to any student. And the length of the array would be the length of ratings array because those many children we have and we have to give 1 candy to each child. After that, we do a first left pass. So for I in range, and what would be the range? Range would be 1 to length of the ratings. We are skipping the first index, that is the 0th index value, because it doesn't have a left neighbor, like we discussed in the algorithm explanation. So we'll check if the ratings for I minus 1 index, that is the left neighbor, is less than ratings which is the current index. If that is true, in that case, the candy for I index value would be candy of I minus 1 index value plus 1, because the I minus 1 index ratings value is less than the ith index rating value. So hence, you will first take the value of I minus 1 index carries and just add 1 there. So that is your first pass. Now I will do the second pass. So I will check for I in range, and I have to skip the last index because it doesn't have a right neighbor. So I will take length of ratings minus 2, because length of ratings minus 1 is my last index, right? So length of ratings minus 2, so that I can skip the last one, and I'll put in minus 1 with a step sense of minus 1. That's how you do it in Python when you go backwards. Now I will check if ratings of my current index, which is I, is greater than rating of I plus 1, which was my right neighbor. If that is true, you would say that I would reuse the same formula, but instead of I minus 1, I would have I plus 1. But remember, you have already done a left pass. And it might just be that the current value of candy I would be more than whatever candy I plus 1 is. So you have to take that into consideration. Hence, your candy I value would actually be a max of your current candy I value. That is, when you did your left pass, you might have updated saying something to 3 candies or 4 candies. So you cannot overwrite it as is. You will take a max of current candy I value and candy I plus 1, because you will check if the right neighbor has lesser number of ratings when compared to your current index. Then you have to increment the number of candies so that it gets more candies, right? But before doing that, you have to check if it is currently more, right? And then take the max. So that's the entire code. And then what do you return? You return total number of candies. So you can calculate total number of candies and return. So return sum of candy array. And just run the code. It's accepted. Let's submit and see our solution is doing well. Here we have a linear time complexity solution. We are doing 2 passes, one left pass and one right pass. Just skipping the starting indices for both because they don't have left and right neighbors respectively. And we also take a max here rather than just taking the neighbor's candy value and adding 1, because current value might already be more than that. Okay. So I hope you understand the solution. I can skim through the solution for you once more. We first initialize a candy array, that is the number of candies being given to each student based on the ratings. And initialize it by 1, since that is the minimum number of candies you would give. And length we would take is length of ratings, that is the total number of children. Now we'll first do the left pass and compare the current index ratings value with the left index value. And if it is more, if the current index value is more, then we give it the number of candies as its left index candies plus 1. Same we do for the right one as well. In right one, we take a max between current value and whatever the right index candies are plus 1. So whatever is max, we allocate that, and then we return sum of candy. So I hope you understand this solution. If you have a better approach, share it in the comments. I would love to know more about it. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily code challenge. I post one solution video every day, so I would love your feedback on that. Thank you.